James Lovell, commander, Fred Hayes, lunar module pilot, and John Swigert, command module pilot, were poised to further man's exploration of the moon. The mission demonstrates the bravery of the aerospace pioneers. With all systems go, the Apollo 13 project began its climb into space and entered Earth orbit to dock with a lunar landing module called Aquarius. After the docking, the two coupled spacecraft began their journey towards the moon. During the first 2 days, the crew ran into a couple of minor surprises. But at 55 hours and 55 minutes, it all started to go terribly wrong. Oxygen tank number 2 blew up, causing the number 1 tank to fail too. Jack Swigert radioed, "Houston, we've had a problem here."
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Indeed, the crew did have a problem. The command module was dead. The Apollo 13 command module's normal supply of electricity, light and water was lost, and they were about 200,000 miles from Earth and heading further away by the second. It was decided that the only option was to use as many of the lunar module's appliances as possible. In essence, the lunar module became a lifeboat. Without it, the 3 astronauts would have died. The first concern was to determine if there was enough consumables to get home. The lunar module was built for only a 45-hour lifespan, and this needed to be stretched to 90 hours. Ground controllers carefully worked out a procedure where the command module's batteries were charged with the lunar module power. Removal of carbon dioxide was also a concern. A warning light showed that the CO2 had built up to a dangerous level. Mission Control devised a way to attach the command module's canisters to the lunar module system by using plastic bags, cardboard and tape, all materials carried on board. Ground controllers in Houston faced numerous formidable tasks, but they all added up to, how do we get them back? Completely new procedures had to be written to determine how, when, and at what altitude to burn the lunar module descent engine to provide a quick and reliable return home. At this point, Apollo 13 was still on its way to the moon, and for any chance of success, it had to round the moon before it could return home. Ground control computed a 35-second burn and fired it up 5 hours after the explosion. As they approached the moon, another burn was completed, this time a 5-minute-long burn to speed up the return home. Now the craft was at least heading in the right direction, towards Earth. More problems were overcome on the way home, but the big moment was when the command module had to be powered up for re-entry. It was full of condensation, and electrical problems were a real concern. However, everything went as planned, and hopes were now high. 4 hours before landing, the crew shed the service module. It was in this module that the explosion took place, and for the first time, the astronauts could see the near-fatal damage that had crippled their command module. The next stage was to jettison the lunar module Aquarius, which had been their lifeboat and saviour. Then began the re-entry, and the crew of Apollo 13 splashed down gently in the Pacific Ocean near Samoa. It was an epic space odyssey, followed by much of the Earth's population, and was later turned into a Hollywood blockbuster, which was directed by Ron Howard and starred Tom Hanks. Howard remarked that the event was accurately portrayed, and there was no need to add drama to the story, as it had all the elements of an epic movie. From those early fragile days to today, not much has changed. Each mission is still perilous. The first launch of the Space Shuttle occurred on April 12, 1981, when Columbia, with 2 crew members, Commander John Young and pilot Robert Crippen, lifted off from the Kennedy Space Center. Photographers, film and television crew and journalists swarmed to witness this historic event. About 600,000 spectators from both the States and overseas flocked to the coastal area to watch the liftoff. If it was successful, the shuttle project would be the backbone of the USA space program and bring forward projects such as the International Space Station. It was exactly 7 a.m. Eastern Standard Time, and the liftoff would mark another great milestone in space research and technology. The world held its breath when the shuttle rose on its column of exhaust. The solid rocket boosters contain the solid fuel that provide about 71% of the vehicle's liftoff thrust. They were jettisoned 2 minutes after launch at a height of 36 nautical miles. They deployed parachutes and landed in the ocean to be recovered. Next, Columbia was prepared for MECO, or main engine cutoff. At this point, Columbia was in space and travelling at over 18,000 miles per hour. The external tank, which holds 500,000 gallons of liquid hydrogen and liquid oxygen, was released 8.5 minutes after launch at an altitude of 60 nautical miles. Once in orbit, the machine and the crew were put to the test. First test, open the payload doors. A space radiator cooling system is exposed when the doors are opened, and this provides the required cooling of the shuttle's electronics. A following test was conducted to check the flight control systems and control surfaces. The shuttle was one of the earliest aircraft to use a computerized fly-by-wire digital flight control system. While the astronauts were completing their objectives, NASA's California Dry Lakes were becoming a hive of activity as nearly 500,000 visitors rumbled into the base to view the spectacular scene of the first ever reusable winged spacecraft glide to touchdown. Back in space, the crew of Columbia prepared for re-entry. The vehicle began re-entry by firing the engines in the opposite direction to the orbital motion for about 3 minutes. This firing was done roughly halfway around the globe from the landing site. The shuttle did a number of arcs and altitude maneuvers to wash off its Mach 26 velocity. Columbia was first sighted by long-range cameras at about 100,000 feet over Anderson Peak in California. The shuttle was decelerated from 26 times the speed of sound to 216 miles per hour. While it completed 2 roll reversals to wash off speed, the shuttle's exterior was subjected to 2,500 degrees Fahrenheit. No test of this stress could be simulated on Earth, and the astronauts were relying on the accuracy of NASA's engineering calculations of this critical phase of the mission. Although the mission was highly successful, a worrying event did occur. While in space, the crew noticed some missing tiles and damage on an engine pod. Also, a little publicised detail about the first shuttle mission was that hot gas entered a wheel well on re-entry, which buckled the right main landing gear on touchdown. Were these the signs of things to come? 2 shuttles have been lost, and their loss reminds us that space travel is still perilous. Yet our human sense of discovery drives us on to explore the unexplored. The first shuttle flight is testimony to this.